Hi everybody. My name is Gita Somit. I am from VVT College. So, today I am going to discuss about priority scheduling in operating systems. So, let us see the what is meant by priority scheduling. Priority scheduling algorithm is an algorithm. It is one of the most common scheduling algorithms in batch systems in operating system. Each process is assigned a priority. Process with highest priority is to be executed first, and so on. The highest priority process will be executed first, and the same priority are executed on first and first come basis. So here we can see that each process is assigned a priority. Process with highest priority is to be executed first, and so on. Process with the same priority are executed on the first come first serve basis. So here we can understand that each process is assigned a priority, and the highest priority process will be executed first, and the same processes having same priority are executed on first come first serve basis. So that is nothing but FCFS algorithm. So priority can be decided based on memory requirements, time requirements, or any other resource requirement. So the priority of an algorithm is given by based on considering many different conditions and requirements. So what is the advantages to use this priority scheduling algorithm? The advantages are easy to use, processes with higher priority execute first, which saves the time. The importance of each process is precisely defined. A good algorithm for applications with fluctuating time and resource requirements. So for applications with having fluctuating time and resource requirements, these are very advantageous. So let us consider an example. So before going into an example, we will also see the disadvantages. So there are mainly three disadvantages of priority scheduling. They are: we can lose all the low priority processes if the system crashes. This priority can cause starvation if high priority processes take too much CPU time. The low priority process can also be postponed for an indefinite time. So if the high priority process takes more time, then then the other process must be in a starvation mode, so that they goes into an indefinite time. So they are not getting chance to execute. So it can lead to the data leakage, etc. So there is a chance that the process can't run even when it is ready, as some other process is running currently. So these are main disadvantages occurs in priority scheduling. Let us see an example. So as we have seen here, a table given with P number or a PID, priority assigned to the each process, arrival time, burst time. These completion time, turnaround time, and waiting time must be calculated by yourself. So in the question, we will be only given to uh, the column only burst time column we will be having given. So the completion time, turnaround time, and waiting time will be calculated by the student. So process ID, there are 7 processes, each one having P1, P2, and so on P7. Each process assigned with the priority. So like first process having 2, second process is having 4, third process is having 6, and so on. So out of these, priority 6 process 6 having priority 12, which is the highest priority, and priority process number 1 having the lowest priority, as I have indicated here with L and with H. Arrival time given. So for each and every process, arrival time is 0, 1, 2, and so on 6. Burst time is given for each and specific process, that is 4, 2, 3, etc. So our main aim is to calculate the waiting time and turnaround time for each and every process. So for to execute these types of problem, we need to take a ready queue. Ready queue is nothing but it places all the proper processes in a queue based on their arrival times. Now, as we are discussing about priority scheduling algorithm, we need to also consider the priority of each and every process, such that highest priority process will be executed first. So in this ready queue algorithm, ready queue, we have placed here P1, but P1 is given with a low priority. We have executed P1 first because it has a low priority. So low priority, but it has having arrival time 0. So it is the beginning of the process. So ready queue begins with the 0 arrival time. So we prefer generally arrival time than the priority. So 0 is taken as arrival time, and at the time of 0, P1 process arrival. We doesn't consider any priority at the arrival time, at the initial stage of arrival time. So P1 process is executed for the for its burst time. So it is executed for the four time interval, as burst time given is 4. Now again, after P4, As arrival time is 4, there are many processes like P2, P3, P4 and P5. Out of these P2, P3, P4 and P5, the highest priority having is P4 because it has its priority as 10 compared to both P2, P3 and P5. So P4 is executed until its burst time. So here P4 burst time is 5. It is executed until completion of its burst time. So 5 is executed here. So 4 plus 5 gives you 9. So here we are going to take non-preemption. If we have considered preemption, the case would be another different way. But we have considering non-preemption. So each and every process must and should complete execute in their burst time. So P4 is executed and P1 is executed up until their burst time. So we have got under we have arrived to 9. The arrival time is 9, and now at the arrival time 9, all the process have entered, both P2, P3, P5, P6, P7, because P1 and P4 are already executed. Out of P2, P3, P5, P6, P7, P6 is having more priority because P6, as P6 is having more priority, it is executed first until its burst time. So after P4, P6 is taken into the consideration in the ready queue, and 9 plus 4, as burst time is 4, we will add 4 to the burst time. 9 plus 4 gives you 13. So we have as 13 as each and every process is occurred. Now we will consider the priority taken by each and process. After P6, P4, P1, P6 are completed. After P6, we have P7 because the priority is 9. Out of all the other processes, P7 is having more priority. So we will execute P7 until its burst time is 6 interval. Up to 6 interval, 13 plus 6 gives you 19, and P7 is executed in the interval 13 to 19. After P7, as P7 is also completed, we are remaining with P2, P3, P5, P2, P3 and P5. Out of these P2, P3 and P5 is having priority 8. So compared to P2 and P3, P5 is having priority 8. So it will be executed in the ready queue. So 19 plus its burst time is only 1. As burst time is 1, it will be executed only for one time. That is 19 plus 1 only 20. After 20, P2 and P3 will be remaining, and P2 out of P2 and P3, P3 is having highest priority. So this is executed first. So after P5, P3 is executed until its burst time because its burst time given is 3. So 20 plus 3 gives you 23. So until in the time interval 20 to 23, P3 is executed, and the last remaining process is P2. It is having the low priority, and it is executed lastly with having burst time 2. 23 will be 25. So here the most important point is nothing but at initial stage of arrival time we have considered P1. As P1 is not having any highest priority, we have considered P1 because of its early arrival time. So as arrival time is early, we have considered P1 as to be executed first. Otherwise, the scenario would be in different way. The after P1, we have executed each and every process according to the priority. So this is nothing but priority algorithm. It has different advantages, disadvantages, but mostly advantages are we can use with the fluctuating time intervals, and also each and every process is defined up to its priority, so that high priority is executed first and low priority is executed later. So this is about priority scheduling algorithm. Thank you one and all for watching my video.